In the examples we have written so far, we have been writing several methods, and every time the method implementation is written inside a class. We never opened a file and started writing the method definition directly. We always wrote first the class name, and then inside the class we wrote the method definition. Now, when we call a method, when we invoke a method, Java needs to know where to find the body of that method. Where is it going to get the statements that need to be executed when we call a method? How have we solved this problem so far? Every time we call a method, we call it through an object. So we have object name, dot operator, method name. For instance, when we created the tree class and then we started creating tree objects. For instance, the T1 tree object. We first created that and then we invoked the getRadius method through T1. Then when Java sees this line of code, it knows that since T1 is of type tree, it needs to go to the tree class, and this is where it will find the definition of the getRadius method. Methods like getRadius, which are defined in this way, are sometimes called object methods or instance methods, because they are tied to the object, to the instance of the class. There is a different kind of methods which are called static or sometimes class methods. These methods, and we have seen examples of those, are invoked by not using the object name, but using the class name and then the dot operator and then the method name. Examples we have seen so far are methods from the math class, like math.sqrt, or methods from the string class, like string.format, or the wrapper classes, or the arrays class. We have seen several instances, several cases of static methods. We can even define our own static methods in our code. All we have to do is place the keyword static at the header of the method that we are writing. For example, if we write static boolean isLeapYear in the parentheses int year, that will mean that the isLeapYear method is now static. It can be called by class name dot isLeapYear. When Java sees this expression that I just mentioned, leapYear dot, where leap year is the class name, dot isLeapYear and some argument, then it knows that isLeapYear ought to be a static method because leap year is the name of the class. It also knows that it will find the implementation of this method inside the leap year class. Much more familiar example to you, you've written down so many times this line of code, public static void main. The main method is an example of a static method. In the same way, or better in a similar way, that we have instance methods and class or static methods, we also have two kinds of variables. We have instance variables and class variables. An instance variable belongs only to a specific object. Every object that we create from a class has its own instance variable. Class variables, on the other hand, are shared by all objects of the class. This is a way through which we can have actually objects of a class communicate with each other. If one object changes the value of a class variable, then that value is reflected to all objects of the class. If we want to declare a class variable, then all we have to do is place the keyword static in front of its definition. Here is an example where we can take a look at static variables and methods. You have seen before different flavors of the tree class. This is yet one more. Take a look at the fields in the class. We have two variables, number of trees and circumference. One is a class variable, the other is an instance variable. Inside the constructor of the tree class, we do something to each of those variables. What do? The circumference is an instance variable, so every time the constructor is called, every time we create a new tree, it gets assigned its own circumference through the value that is provided in the constructor. On the other hand, every time a new tree is created, all we want to do is accumulate that piece of information. So we increase the number of trees variable by 1. Remember that all of the tree objects share a single copy of the number of trees variable, because that is a class variable. All of the objects have exactly the same value for that variable. On the other hand, every object has its own circumference. Every tree will have its own copy of the circumference variable. Now, if you take a look at the main method in our program, we create one tree, but even before we create any object of the tree class, we can already go and call a static method through the name of the class. And what will this getNumberOfTrees method do? It will return the value of the static variable. We can do that even before creating any object of the class. And you can also see that the NumberOfTrees variable, the class variable, has been initialized to 0. We can also call the getNumberOfTrees after we have created tree objects. Now that we have created one tree, the number of trees value will have changed. It was 0, we now expect it to be 1. Why? Because the constructor updates the value of this variable. And finally, we can call instance methods again through the object t1, getRadius, and that will give us a value that depends on the circumference of that particular tree object.